Hello dear students, in our last class we had a discussion on linear programming problem exercise 12.2. So in this class we are going to the miscellaneous example and miscellaneous exercise problem. ನೋಡಿ ನಾನು miscellaneous exercise example problem ಸಾಲ್ವ್ ಮಾಡಿಸ್ತೀನಿ. ಇಟ್ ಮೀನ್ಸ್ here ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ ಅದಕ್ಕೆ ತಕ್ಕಂತ ಆಬ್ಜೆಕ್ಟಿವ್ ಫಂಕ್ಷನ್ ಕನ್ಸೆಂಟ್ಸ್ ಸಾಲ್ವ್ ಮಾಡಿಸ್ತೀನಿ. ದೆನ್ ರೆಸ್ಟ್ ಆಫ್ ಥಿಂಗ್ಸ್ ಫೈಂಡ್ ದ ಫೀಸಿಬಲ್ ರೀಜನ್ ಅಂಡ್ ಸೊಲ್ಯೂಷನ್ ನೀವೇ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್, yes slide. They are the example 9. A dietitian has to develop a special diet using two foods P and Q. Each packet, so one packet is equal to 30 gram of food P contains 12 units of calcium, 4 units of iron, 6 units of cholesterol and 6 units of vitamin A. Each packet of the same quantity of food Q, that is there 30 gram, contains 3 units of calcium, 20 units of iron, 4 units of cholesterol and 3 units of vitamin A. The diet requires at least means here 240, at least 240 units of calcium, at least 460 units of iron and at most 300 units of cholesterol. It means here it never exceed 300 units of cholesterol. Okay, how many packets of each food should be used to minimize the amount of vitamin A in the diet? What is the minimum amount of vitamin A? Here we need to minimize the amount of vitamin A, so which are used in food P and food Q. Okay, so listen here. So what are the important things? So they given two types of food P and Q. Okay, so they develop two types of food P and Q. So each food P contains here, so what are the important things here? So food P contains 12 units of calcium, 4 units of iron, 6 units of cholesterol and 6 units of vitamin A. And each packet contains of the same food Q contains 3 units of calcium, 20 units of iron, 4 units of cholesterol and 3 units of vitamin A. These are the things here. Okay, the diet requires at least means here the diet at least contain minimum amount is here 240, at least containing 240 units of calcium, at least 460 units of iron and at most the maximum amount used to develop these two foods here 300 units. It cannot exceed 300 units. So of the cholesterol, so how many packets of each food should be used to minimize the amount of vitamin A in the diet? What is the minimum amount of the vitamin A? Next slide. So, first and foremost thing is here, so convert the entire problem to mathematical form, right? So mathematical form munche, so what is the important thing here? Here we have to take the decision variables and they are non-negativity. Just observe here. Let x be the number of packets of food P and y be the number of packets of food Q. Next, when you convert the entire problem to mathematical form, you get this table. So what are the resources we are using to develop food P and food Q here? Calcium, iron, cholesterol and vitamin A. Right. So to develop a food P, it contains 12 units of calcium, 4 units of iron and 6 units of cholesterol and 6 units of vitamin A. So food P na nಮಗೆ x numbers ಇದೆ. So x number of packets of food P. So it means here 12 into x become total amount of calcium used to develop food P. Similarly 4x represent total amount of iron, cholesterol become the 6x become total amount of cholesterol and 6x become total amount of vitamin A. So these are the calcium, iron, cholesterol and vitamins used to prepare food P. Similarly for the food Q observe ಮಾಡಿದಾಗ, so food P Q ಎಷ್ಟಿದೆ ನಮಗೆ? We are taken y number of food Q, right? So y packets, y number of packets of food Q ಇದೆ. So for calcium, to develop a food Q, it requires 3 units of calcium, that become 3y, 20 units of iron, that become 20y, 4 units of cholesterol, that become 4y and 6 units of vitamin A. 6 units of vitamin A. So that become 6y. And also given restrictions or availability. So what is the availability here? The calcium, the amount of calcium is at least 240 units here. That is greater than equal to 240. That is iron also, it is at least 460 unit. It means here the amount of iron what we are used to develop the food P and food Q must contain at least 460. It means here 460 is the minimum. It can exceed 460. So what about cholesterol here? Cholesterol is here at most ಕೊಟ್ಟಿದ್ದಾರೆ. What is the things here? At most. So total amount of cholesterol or total units of cholesterol used to develop food P and food Q, it cannot exceeds 300. It cannot exceeds 300. Become 6x plus 4y less than or equal to 300. So what is the important thing here? Here we need to minimize the amount of vitamin A, right? Minimize the amount of vitamin A. So 6x represent the amount of vitamin A used to develop food P. Similarly for 6y represent used for food Q. So total amount 6x plus 6y represent total amount of vitamin A used to develop food P and food Q. So what are the objective here? So objective function enagtari. Objective function. So here we need to minimize. What is that? Minimize the total amount of vitamin A, right? That becomes. So it is 6x for food P and 6y for food Q. So total that become here Z. So Z is equal to 6x plus 6y. That become our objective function. So what are the constants? Constants ಏನಿದೆ ನೋಡೋಣ. First one observe ಮಾಡಿ. First one here 12x plus 3y is greater than equal to 240. Right? Second one for iron 4x plus 20y greater than equal to 460. And the third one 6x plus for cholesterol 4y is less than equal to 300. Just observe here, less than or equal to, because this is the at most at maximum amount is here 300 units. So and also x greater than equal to 0, y greater than equal to, because they are the non-negative constants. So this is our objective function, this is our constants. So after opening the objective function and constant, what is the next step? Next step we need to find the feasible reason, right? Next slide. Just find the feasible reason for these constants. So the feasible reason is bounded. Okay, again feasible reason barutte, that is bounded feasible reason. Next, the minimum value of Z is 150 at the point 15, 20. Okay, the minimum value of Z objective function Z is here 150 at the point 15, 20. Next, thus the amount of vitamin A will be minimum if 15 pockets of food P and 20 pockets of food Q are used in special diet. The minimum amount of vitamin A will be 150 units. Clear? The minimum amount of vitamin A will be 150 units. This is the example 9. So this problem is very important. Let's move on to the next problem. Now look at the example 10. This is also very important for exam point of view. So look at the problem here. A manufacturer has 3 machines 1, 2 and 3 installed in his factory. Machine 1 and machine 2 are capable of being operated at most 12 hours. Here, so what they given here, at most 12 means here the total number of hours operated by the machine A, that is the machine 1 as well as the machine 2, it cannot exceed 12 hours. Right? So whereas the machine 3 must operated for at least 5 hours. So it means here machine 3 must operated at least 5 hours in a day. She produces only 2 items M and N, each requiring the use of all the 3 machines. The number of hours required for producing 1 units of each item M and N on 3 machines are given in the following table. Just observe the table. Items here M and N, they given 2 items M and N. The number of hours required on machines machine 1, machine 2 and machine 3. This is your machine 1, machine 2 and machine 3. To produce 1 units of item M, it requires 1 hour on machine 1, 2 hours on machine 2 and 1 hours on machine 3. Similarly, for to produce 1 units of item N, it requires 2 hours on machine 1, 1 hour on machine 2 and 1.25 hours on machine 3. So now she makes a profit of 600 and rupees 400 on items M and N respectively. How many of each item should she produce so as to maximize her profit, assuming that she can sell all the items that she produced? What will be the maximum profit? What will be the maximum profit? There is a WILL. What will be the maximum profit? Just observe here. So first and foremost thing is here, convert the entire problem to mathematical form. Right? So mathematical form kododikina modlu first you can observe here. First you take the decision variables. So what are the decision variables? You have to take here non-negative decision variables, x greater than equal to 0 and y greater than equal to. Okay, so here we taken the decision variables x and y. They are the decision variables and they are non-negative. Let x and y be the number of items M and N respectively. Then next, so here we have machine 1, 2 and 3 and item M and item N, and we have the last column is here availability. Just observe here, to produce the machine M, so to produce the item M, it requires 1 hour on machine 1, that become 1x. Similarly 2 hours on machine 2, that become 2x, and 1 hours on machine 3, that become 1 into x, that is nothing but x. Similarly for to produce the item N, it requires 2 hours on machine 1, 1 hours on machine 2 and 1.25 hours on machine 3. Right? So and also given availability. Okay, so what is the availability here? Machine 1 and machine 2 can operate at most 12 hours in a day. At most 12 hours in a day means here it cannot exceed 12 hours of work hours of machine 1 and 12 hours of machine 2. And also given for third one, the machine 3 can operate at least 5 hours in a day, that become greater than or equal to 5. So and also given profit. So from item M they obtained the profit here 600 rupees. Similarly for x number of item become 600 into x. Similarly for item N 400 into y, that become here 400 rupees for one item of N. Here we have the y number of item N, that become 400 into y. So what are the objective function here? Here we need to maximize the profit, right? What is the objective function? Objective function z is equal to, what is z is equal to here? 600x plus 400y. Here we need to maximize this objective function 600x plus 400y. So what are the constants? Observe the constants here. So what will the constants here? First one, for machine 1, x plus 2y less than or equal to 12. X plus 2y less than or equal to 12. And the second one, 2x plus y less than or equal to 12. Okay, 2x plus y less than or equal to 12. For the third one, x plus 1.25 hours of y is greater than or equal to 5. Clear? Okay, now so 1.25 is there. So decimal, I will write in the fraction for that, it become x plus, I will write here 5 divided by 4 into y is greater than or equal to 5. This become third constants. Okay, so you have to replace this constants by this one. X plus 5 divided by 4 into y greater than or equal to 5. We can take care of 5 as LCM, that become 4 as LCM, 4 into x become 4x plus 5 into y is greater than or equal to 5. Now take the cross multiplication, this become 4x plus 5y greater than or equal to 4 5s are 20. Okay, so the entire this one constants x plus 1.25y greater than equal to 5 is replaced by 4x plus 5y greater than equal to 20. Is it clear? Okay, next. So what are the non-negative conditions here? X greater than equal to 0 and y greater than equal to 0. So what is the next step? Next step is very simple. Find the feasible reason for these constants. Here we have constants and here we have another constants here. So after finding the feasible reason, next step we need to find the corner points, right? Next slide. Okay. So the feasible reason here bounded. Next. The maximum value of z is 4000, where it attains here at the point x is equal to 4 and y is equal to 4. Next slide. Thus, the manufacturer has to produce 4 units of each product to get maximum profit of 4000. It means here they have to produce 4 items of M and 4 items of N. Okay, item M and N, they have to produce here each 4 items, 4 units, then we get the maximum profit, and the maximum profit is here 4000 rupees. So where it attains here at the point x is equal to 4 and y is equal to 4. Solve these problems here, and first example 9 and example 10 are the homework problem. And next we are moving to the exercise miscellaneous questions. So miscellaneous exercise problems on linear programming problem. So adರಲ್ಲಿ ನಾವು one problem discuss ಮಾಡ್ತೀನಿ. So this problem is very important and the rest of the problems for homework questions. Clear? Okay. Next slide. Okay. Miscellaneous, next previous. Miscellaneous exercise problem. Question number 5 is very important. An aeroplane can carry a maximum of 200 passengers. A profit of rupees 1000 is made on each executive class ticket and a profit of rupees 600 is made on each economy class ticket. The airline reserves at least, this observe here, the airline reserves at least 20 seats for executive class. However, at least 4 items as many passengers prefer to travel by economy class than by executive class. So determine how many tickets of each type, it means here executive class and economy class, must be sold in order to maximize profit. Here we need to find the maximize the profit for the airline. What is the maximum profit? Problem is clear? Okay. Just observe the problem and note on the problem. Take a pause and note on all the problem. Okay. Now observe here. So what are the important things we observe here? An aeroplane can carry maximum 200 passengers. Just observe here, maximum 200 passengers. So what is the maximum space availability here? You can take here space antanu tagobodu. So maximum availability here 200 passengers. A profit of rupees 10,000 is made on each executive class and rupees 600 is made on each economy class tickets. Right? The airline reserves at least 20 seats for executive class. The airline must reserve at least 20 seats for executive. At least means here minimum 20 seats. However, at least 4 times as many passengers prefer to travel by economy class than by executive class. This is very important, right? So 4 times as many passengers prefer to travel by economy class than by executive class. Okay. Determine how many tickets of each type must be sold in order to maximize the profit for the airlines. What is the maximum profit? What is the maximum profit? What is the first method here? First you have to take the decision variable. I have taken let x be the number of executive class tickets to class tickets. Okay, let x be the number of executive class tickets and y be the number of economy class tickets, right? Economy class tickets. So directly I will write the objective function. So what is your objective function? Our aim or goal of the problem tells the objective function. What is our aim here? Here we need to maximize the profit. So objective function z is equal to, take the z. See, you opened rupees 1000 on each executive class. So for one ticket of executive class you opened 1000 rupees. For 2 that become 1000 into 2. For 3 that become 1000 into 3. Here we have the x number of executive class ticket, that become 1000 into x plus. This is the total profit obtained by the airlines by executive class ticket, right? Okay, 1000 into x height. So similarly, so from the one economy class ticket you obtain the profit of rupees 600. You obtain the profit of rupees 600. So that become 600 for one ticket. For 2 ticket 600 into 2. For 3 tickets 600 into 3. Similarly for y number of ticket for economy class, that become 600 into y. 600 into y. This is our objective function. Clear? So objective function agutte z is equal to 1000x plus 600y. This is the objective function. Then we have to go with their constraints, right? So what they given here? First observe modi, an aeroplane can carry maximum 200 passengers. So the economy class is executive class here x number of passengers and y be the number of economy ticket, means that is y number of passengers. So total number of passengers is x plus y, right? So total number of passengers it cannot exceed 200 because the available space is here 200 passengers. Clear? Given, what is given here? Aeroplane can carry can carry 200 passengers or maximum 200 passengers. So when you convert to mathematical form, what you happened here? This is for executive class and y for economic class. It cannot, total number of passengers cannot exceed 200. That become less than equal to 200. Less than equal to 200. Okay. Second thing. What is second thing here? The airline reserves at least 20 seats for executive class. The airline reserves at least 20 seats for executive. For executive class, okay, for executive class, at least 20 units. So I will take here. What is x here? X is the number of tickets of executive class. So at least here, so x greater than equal to, I'll write here, which implies x greater than equal to 20 agutte. At least the airline must reserves at least 20 seats for executive class. X greater than equal to 20. Next is very important. The airline, however, at least 4 times as many passengers prefer to travel by economy class than by executive class. This is very important. Just observe here. 4 times as many passengers prefer to travel by economy. Okay. So, economic class is I'll write here. Same work. At least 4 times as many passengers prefer to travel by economy class than by the executive class. Okay, just leave it. Come to here. I will take note. So A and B are the two numbers. What is A and B are the two numbers? I will say number A is 4 times greater than number B. Is 4 times greater than number B means ಏನು ಬರೀತೀವಿ? Number A is 4 times greater than number B. ಅಂದರೆ ಏನಾಗುತ್ತೆ? A is greater than 4B ಆಯಿತು. A is greater than 4B. Similarly, when you convert to this form to mathematical form, it means here the economy class Y, the economy class Y, the total number of economy class Y must be greater than or equal to 4x ಆಗುತ್ತೆ. Greater than equal to 4x. It means here economy class ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾರಲ್ವಾ, Y number of tickets or Y number of passengers must be greater than equal to 4 times as many as executive class. 4 times as many as executive class. This is here Y greater than equal to 4. I repeat again, at least 4 times as many passengers prefer to travel by economy than by the executive class. So economy class ಅಲ್ಲಿ travel ಮಾಡೋ passengers must be greater than equal to 4 times as many as executive class, that is Y greater than equal to 4x. This thing is very important, this step is very important. Y must be greater than equal to 4x. Clear? Y must be greater than equal to 4x. So take a pause and write down all the things what I written here. Okay, next is, so here we have objective function and constants ಬಂದಿದೆ. Okay, ಬರ್ಕೊಳ್ಳೋಣ. Now we will solve this problem. So before going to problem, first we will note down objective function corresponding constant. Blank space please, blank space. Okay, so here maximize what? Maximize profit, right? Maximize Z is equal to what is here? 1000x plus 600y. Maximize Z is equal to 1000x plus 600y. That is objective function. So what are the constants here? Constants observe money. Constants. First one is here x plus y less than equal to 200. Second one x greater than equal to 20. Third one y greater than equal to 4x and x greater than equal to 0, y greater than equal to 0. They are the non-negative constants. Clear? This thing is very important, y greater than equal to 4x. Okay, so repeat ಮಾಡ್ಕೊಂಡು ನೋಡ್ಕೊಳ್ಳಿ, this is very important, y greater than equal to 4x. So these are the constants. So after operating the constant, what is the next method? Find the feasible reason, right? Find the feasible reason. Okay, first term, the equations involved in the above inequalities inequalities are, first one here x plus y is equal to 200, second one x is equal to 20 ಬರ್ಕೊಳ್ಳೋಣ, third one y is equal to 4x. Y is equal to 4x. For first one, from the point of intersection of the line x plus y is equal to 200 on y axis, substitute x is equal to 0. That becomes 0 plus y is equal to 200. What is y then? Y is equal to here 200. So corresponding point become 0 comma 200, right? 0 comma 200. Next, and put y is equal to 0 here in the above equation, so that become x plus 0 is equal to 200. But x is equal to then? X is equal to 200. The point become 200 comma 0. This is the point of intersection of the line x plus y is equal to 200 with x axis. Now come to the line x is equal to 20. So what is x is equal to 20? X is equal to 20 is nothing but it is a vertical line. Vertical line at x is equal to 20. and x is equal to 20. Now come to the next one, y is equal to 4x ಇದೆ. Just observe here, y is equal to 4x. So general form ಏನಂತ ನಮಗೆ y is equal to mx where the line passing through origin. Here also y is equal to 4x is the line passing through what? Origin. The line passing through origin. Okay. ಅದಕ್ಕೆ ಮಾಡ್ತೀವಿ put x is equal to 0. What do you happened here? Y is equal to 4 into 0. That is nothing but y is equal to 0. What is the corresponding point here? 0, 0. So one point here 0, 0. That is here origin. It is not a problem. So when come to the second one, second point because to draw the line we require at least 2 points, right? One point is here 0, 0. What about second point? Substitute any one. I will take here x is equal to 20 ತಗೊಂತೀನಿ. Or x is equal to 30, x is equal to 40. You can take any value here. X is equal to 10, x is equal to 20. ಏನು ಅರ್ಥ ಹೇಳಿ? I will take here. Because here where the previous value is x is equal to 20, I will take here. Put x is equal to 20 here. What is y then? Y is equal to 4 into 20. That become y is equal to 80. When x is equal to 20, y become 80. So corresponding point become here 20, 80. X is equal to 20 and y is equal to 80. This is the point of, so one point here is 0, 0, second point 20, 80. So now second step is here, we have to check whether the solution region is towards the origin or away from the origin. Towards the origin or away from the origin, right? Okay. Now take the inequality. X plus y less than equal to 200. X plus y less than equal to 200. Put x is equal to 0 and y is equal to 0. Put x comma y is equal to 0, 0. What will happen here? 0 plus 0 less than equal to 200. 0 less than equal to 200. This is nothing but true. In solution region is towards origin. Solution region is towards origin. Clear? Okay. Come to second one. Second one observe ಮಾಡಿ. Second inequality ಏನಿದೆ ನಮಗೆ x greater than equal to 20. X greater than equal to 20. So x greater than equal to 20 means here. So this solution region when you substitute only, if you substitute here x is equal to 0 noda. Is it 0 greater than equal to, or put same method here. Put x comma y is equal to 0, 0. Substitute both x is equal to 0 as well as y is equal to 0. This becomes 0 greater than equal to 20. 0 greater than equal to 20. It means it is false because 0 is always less than 20, right? So once 0 greater than equal to 20, this statement is false. Hence solution region is away from the origin. This is very important. Away from what? Away from the origin. Clear? Okay. Next is very important. Y greater than or equal to 4x. Y greater than equal to 4x. How to solve this one? If you substitute x is equal to 0 and y is equal to 0, 0 greater than equal to 0 ಆಗುತ್ತೆ. It is highly impossible to find whether the solution region is towards or, because the line is passing through origin, right? When so y is equal to 4x is a line passing through origin. So ಅವಾಗ ಏನು ಮಾಡ್ತೀನಿ ಅಂದರೆ, so I will take the point either on x axis or y axis. Take the point either y axis or x axis. When you substitute the point in the inequality, if the inequality is true, then the solution region is towards corresponding axis. Okay. So first I will take the point on x axis. X axis ಅಲ್ಲಿ ಪಾಯಿಂಟ್ ತಗೊಂಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ in this inequality. So suppose the inequality is true, then solution region is towards the x axis. Suppose the inequality is false, the solution region is away from the x axis or towards y axis. Okay. First take the point. ಇಲ್ಲಿ ನೋಡಿ ಇದೆ ಪಾಯಿಂಟ್ 0, 200 ಇದೆ, 200, 0 ಇದೆ. You can take any one of the point. If you take 0, 200, that become 200 is greater than equal to 0. 200 greater than equal to 0 ಆಗುತ್ತಾ? Substitute when you substitute here ನೋಡಿ 0, 200 ಇದೆ, 200 greater than equal to 4 into 0 because 200 greater than equal to 0 ಆಯಿತು. Obviously this inequality is true. Hence solution region is towards y axis. Clear? Similarly, if we substitute the point on x axis 200 comma 0 idu, x is equal to 200 and y is equal to 0. So what do you happen here? 0 greater than equal to 800 agutte. Obviously 800 is greater than 200, not greater than 0, not 0 greater than 800. So this inequality become false. Hence the solution region is away from this point, or you can say another word here, the solution region is towards the y axis. Clear? Okay. So for that purpose you can take any point, but I will take the point here on y axis. Take the point, put x comma y is equal to, what is the point nodi? 0 comma 200 ತಗೊಂತೀನಿ. 0 comma 200. So that become y is here 200 greater than equal to 4 into 0. That become 200 which implies 200 greater than equal to 0. So this statement is here true, right? This statement is true means here solution region is including, what is the point here? 0 comma 200. Where it points occurs here? At y axis. So the solution region is towards y axis. Towards y axis. Clear? Okay. This is the things. Okay. So take a pause and note on all things what I written here. So now we will draw the graph for these inequalities. So before going to draw the graph, first we should take the scale along x axis as well as the y axis. 1 centimeter is equal to 20 units. Take scale along x axis as well as the y axis along 1 centimeter is equal to 20 units. So first we will draw the line x plus y is equal to 200. The line here x plus y is equal to 200 and corresponding point of intersection with the y axis 0 comma 200 and with the x axis 200 comma 0. First take the point 0 comma 200 and 200 comma 0. So join these 2 points, use the scale while joining these 2 points. You get this line. What is the line? X plus y is equal to 200. X plus y is equal to 200. Clear? Okay. Next, x is equal to 20. What is x is equal to 20? It is a vertical line, right? So vertical line, so which passing through the point at x is equal to 20. You will get this line. Put a line here, x is equal to 20. You can extend this to x is equal to 28. So just observe for x plus y is equal to 200, corresponding inequality x plus y less than or equal to 200. When you substitute x is equal to 0 and y is equal to 0, the solution region is towards the origin, right? Towards the origin. Idನ್ನು draw ಮಾಡ್ತೀನಿ. Towards the origin. Here we have origin. Similarly, x greater than or equal to 20. Observe the second inequality here. X greater than or equal to 20. It means if you substitute x is equal to 0 and y is equal to 0, inequality become false and solution region is away from the origin. So this is your origin. Away from the origin means here just write to the line x is equal to 20. Write to the line x is equal to 20. So this represent the solution region for the line x is equal to 20 or x greater than or equal to 20. But next, so we have the third inequality, y greater than or equal to 4x, and corresponding equation is here y is equal to what? Y is equal to y is equal to x, 4x. Y is equal to 4x and corresponding points 0 comma 0, another one here 20 comma 80. So first point here 0, 0. Another point here 20, 80. You will obtain here this point. So join these 2 points. ಎರಡು ಪಾಯಿಂಟ್ ಅನ್ನು ಜಾಯಿನ್ ಮಾಡೋಣ. And continue the line. So what is the line? Y is equal to 4x. Y is equal to 4x. Clear? When you substitute the point on y axis, that is 0, 200, this inequality become true, hence the solution region is towards y axis or towards this point. What we are where is the point here? 0, 200 point illide, so towards this point. ಈ ತರ ಆರಂಭ ಡ್ರಾ ಮಾಡೋಣ. And also non-negative constants, x greater than equal to 0, y greater than equal to 0. This will be y greater than equal to 0 and x greater than equal to 0. Okay, this is a line. Next step, we need to find the feasible region. What is the feasible region? The common region determined by all the constants including non-negative constant. That region what we call as a feasible region. Just observe the region. So what you obtained here, this one. So here also y greater than equal to 4x satisfies, x greater than equal to 20 satisfies, and x plus y less than equal to 200, that is also satisfied. X greater than equal to 0 satisfies, y greater than equal to 0, that is also satisfied. What is the region here? This region what we call a feasible region. ಇದನ್ನ ಶೇಡ್ ಮಾಡ್ತೀನಿ. This region what we call as the feasible region. Clear? This region what we call as a feasible region. ಇಲ್ಲಿ ಬರೀತೀವಿ. This region what we call as a feasible region. So now label the points here. This is the point A. This is the point B. And this is the point C. Point C. Okay, point C equilibrium. This is the point C. So how to find the point A? So point A is the point of intersection of the line x is equal to 20 and y is equal to 4x. Now solve this equation. ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡೋಣ. Okay, to find the point A, so one need to solve here. X is equal to 20, one, another one here. Second equation, y is equal to 4x. Direct x is equal to 20, it is not a problem. Substitute x is equal to 20 in the equation. Y is equal to 4 into 20, that become y is equal to 80. So corresponding point become here 20, 80. This is the point A. That is A is equal to here 20, 80. Point A become 20, 80. Clear? Okay. Come to the next one. Next one is y is equal to 4x and x plus y is equal to 200. To obtain the point B, to find the point B, we have to solve the equation x plus y is equal to 200 and y is equal to 4x. Second one, to find the point B, x plus y is equal to 200 and y is equal to 4x. Here, just substitute y is equal to 4x in this equation, we get the value x plus, what is y is equal to here? 4x is equal to 200 ಆಗುತ್ತೆ. 5x is equal to 200. What is x then? X is equal to 200 divided by 5. That become 40. Okay. So what is x value here? X is equal to 40. So what about y then? Just substitute y is equal to here. Y become 40 into what? 4 into 40, that become y is equal to 160. Y is equal to 160. What is the point B then? Point B become 40 comma 160. The point B become 40 comma 160. Clear? Okay. What is next here? Next is important, point C. So how to find the point P? C. This also solve the equation. What are the equation here? To find the point C, we have to solve the equation. X is equal to 20 and another one. X plus y is equal to what? 200, right? X plus y is equal to 200. Substitute x is equal to 20 here. 20 plus y is equal to 200. Y is equal to 200 minus 20. That become y is equal to 180. What is the point C then? Point C become 20 comma 180. The point C become 20 comma 180. That become 20 comma right here 180. 20 comma 180. So we obtain the point A, B and C. So what is the feasible region here? The region A, B, C is called feasible region. So this region what we call as a feasible region, right? From here. So this region what we call as feasible region. So this is what we call as a feasible region. Right. This is the feasible region. So please note down all the things what I have written here. Take a pause and note down all the things what I have written here. So after obtaining the corner points, what is the next step? Next step we need to find the value of the objective function at corner points, right? Okay, next slide please. So what are the corner points here? A of 20, 80, B of 40, 160 and C of 20, 180. Next slide. Next. The values of objective function, that is Z, at corner points are, next, these are the corner points A of 20, 80 and objective function here 1000x plus 600y. When I substitute x is equal to 20 and y is equal to 80, we will get here 68,000. Similarly, when I substitute x is equal to 40 at the point B and y is equal to 160, we obtained here 1,36,000. And when I substitute x is equal to 20 and y is equal to 180, we obtained 1,28,000. So here we need to maximize the profit. That means here we have to maximize what? Objective function. So what is the largest value of objective function? Here we have the largest value, right? Just observe the feasible region. Here the feasible region is bounded, right? The feasible region is bounded. Hence the largest value of the objective function become maximum value. The largest value of the objective function become maximum value. Okay. So because the feasible region is bounded. So from the theorem number 2, so when the region is bounded, the objective function attains its both maximum and minimum value. So when it occurs here at the largest value and smallest value. Next slide. Therefore, the maximum value of Z is 1,36,000 at 40, 160. Okay, next. Thus, 40 tickets of executive class, because X represent, what is X here? So this is here X is nothing but executive class tickets and 160 is nothing but Y, that is here economic class. Thus, 40 tickets of executive class and 160 tickets of economic class should be sold to maximize the profit, and the maximum profit is here 1,36,000. 1,36,000. This is the problem number 5 on exercise, on miscellaneous exercise. Clear? Okay. So here just observe the feasible region. Feasible region is bounded. Hence the largest value of the objective function. What we obtained here? 1,36,000. That become the maximum value. Clear? So and what is here? Maximum when it occurs here at the point 40 comma 60. What is 40 here? 40 is the number of economy tickets or executive class tickets, and 160 is the number of economy class tickets. So 40 tickets of executive class and 160 tickets of economy class should be sold to maximize the profit, and the maximum profit here 1,36,000. Is it clear? Nodi makla, so far we discussed about the linear programming problem or LPP. So you can say another word here, linear programming. So this chapter carries total weightage of 7 marks. This is very important. 1 marks 1 question, 6 marks 1 question. So you have to study both verbal problem as well as the non-verbal problem. Clear? Thank you everyone.